A very good afternoon to all of you. May I request you all to please settle down and keep your mobile phones in the silent mode. Thank you very much. I'm delighted to welcome you all to the first lecture of the INSA-IISER Thiruvananthapuram Distinguished Lecture Series to be delivered by Professor Eluvathingal D. Jemmis from the Indian Institute of Science, Bangalore. To begin with, I would like to invite Professor Jemmis, our guest for the day, Professor J.N. Murthy, our director, Professor Murthy Srinivasula, our deputy director, to kindly come on to the stage. Thank you. I now request Professor Murthy to welcome Professor Jemmis with a shawl. Professor Murthy. Thank you very much. I take this opportunity to profusely thank the Indian National Science Academy, New Delhi, for envisioning and initiating this excellent series of distinguished lectures for the benefit of researchers and for their very generous supports towards organizing these lectures. I would like to thank you all for joining on this delightful evening for the first lecture of the series at IISER Thiruvananthapuram. Let me now formally introduce Professor Jemmis. Professor Jemmis studied chemistry at the University College Thiruvananthapuram and St. Thomas College Thrissur before moving on to the IIT Kanpur to pursue his postgraduate studies. He then joined the Princeton University for his doctoral research under the supervision of Professor Schleyer and Professor Popel. After a postdoctoral stint at the Cornell University with Professor Roald Hoffman, he joined the faculty of the School of Chemistry, University of Hyderabad. In 2005, he accepted an invitation from the Indian Institute of Science, Bangalore, to join the Department of Inorganic and Physical Chemistry as a professor. He is currently serving as a professor emeritus at IISc. During his stay at IISc in 2008, he was invited to take up the responsibility of serving as the founder director of IISER Thiruvananthapuram. On behalf of the IISER Thiruvananthapuram fraternity, I take this opportunity to express our heartfelt gratitude to Professor Jemmis for nurturing the growth of this institution in its formative years. Professor Jemmis' area of research is applied theoretical chemistry with an emphasis on the structure, bonding, and reactivity across the periodic table of elements. The focus of his group has always been on deriving general relationships between structures and properties of various chemical systems. For his research contributions, Professor Jemmis was awarded with the Shanti Swarup Bhatnagar Prize and the TWAS Prize. He is also an elected fellow of the Indian National Science Academy, New Delhi, Indian Academy of Sciences, Bangalore, and the Academy of Sciences for the Developing World, Trieste, Italy. He was honored with the civilian honor Padma Shri in 2014. With these remarks, may I now request Professor J.N. Murthy, our director, to speak a few words and invite Professor Jemmis to deliver the distinguished lecture. Professor
Murthy. Indeed, a very delightful evening to all of you. Nothing could be better. In fact, INSA, for the first time, initiated a series and contacted us to have this IISER TVM INSA lecture series and have some eminent people invited to our campus and have popular lectures. I could not think anybody better. Of course, we do have several scientists, and Professor Jemmis being our founding director, an exceptional scientist with a monumental contributions in chemistry. I thought it's very fitting that we have him on our campus, and which is how we have today INSA-IISER Distinguished Lecture, the first one. Right. I think there are a few lined up, and it's a veritable pleasure. So I welcome you to our campus. It's all our joy. Let's extend a warm welcome to him, all of you, please. Dr. Swati did the honors and talked about his credentials. I don't think that I should talk anything more than my interaction with him and how I came to know of him as a student at IISc, as a PhD student at IISc. That was in 1988. He came back to the country in 1980 with a unique distinction of having worked with the two Nobel laureates, Pope, Ronald Hoffman, and who's the other person? Pope. Yeah, the Nobel Prize, who got the Nobel Prize for DFT theory. And we used to hear about the scientists at University of Hyderabad, of course, a few those days. And if you speak of chemistry particularly, everybody would single out University of Hyderabad as one of chemistry department as one of the best in the country. Aside from a few others, of course, IIT Kanpur and the place that I come from and a few institutions. Exceptional scientists at University of Hyderabad. And even as a student, I knew those days in 1988, 1990 around, that he was doing a marvelous computational chemistry of organometallics. And slowly, I think he has made such contributions that his work now features prominently in the textbooks. I think any amount that I talk about him would be less. Chemistry community knows his contributions really well, and he was also given this responsibility of building these ISERs. And I would like to reflect on the way his heart beats for science in general, in particular for ISER TVM. Right? Wherever he goes, I think, given the fact that 5 years he sweated out here and got the, did all the groundwork for getting the work initiated at this campus, was not easy. It began, I'm sure it began with even identifying the site, getting to this jungle, total jungle. And in fact, yesterday he was telling me that he brought a few students to this particular site and went to the Jersey farm there. And told the students that this is where ISER Tirunanthapuram is going to be. I'm sure if we flash those pictures, none can imagine that we have the place that it was has become what we have today. I don't think anybody can recognize. And initiating the work, getting the design, architectural plan laid out for the campus, and getting the foundations kind of laid for several structures, which were later completed by Professor Ramakrishnan from Madurai Kamaraj University. Of course, he left, and I came back in 2019. He left in 2013, and I came to this campus in 2019. And given that we practice the same profession, I know him quite well. In fact, in 2016 or so, I and him gave a talk in INSA-IISER before Professor C.N.R. Rao, which was a lovely one, which I still treasure those pictures with the Professor Jemmis. And 2019, I think when we had the convocation, I invited him, and I know his passion for this particular institution. In fact, he expressed, I think somebody told me, or he told me himself, that he wanted to kind of sleep in this campus in the guest house, where, not in the guest house, in the director's residence that I have been staying in. I thought, I should let him have that opportunity. It is still not materialized, and I'm sure this will happen one of these days. The thing is, each time I run into him, and he passionately talks about the kind of number of students that he had initially, only in tens of numbers, initial days, when they got started. And he knows by name the students that joined ISER TVM. And just during the lunch, he was talking about 10 or 12 of the students, out of which 3 having become the faculty internationally, 1 abroad and 2 of them within the country. And everywhere he goes, he runs into ISER TVM students. He sends me a WhatsApp message with a picture. Here they are, and I'm really pleased to have our ISER TVM students to be interacting with our ISER TVM students. I think I want to kind of tell you students that he has been a great ambassador for us, upholding the stature of ISER TVM, talking really high of the education that we impart, and putting our students up in the skies everywhere and promoting you guys. I think it's very befitting that we have Professor Jemmis a scientist of exceptional caliber amongst us. Please join me in welcoming him to address us today. Thank you. Professor Jemmis. Thank you.
Prof. Murthy and friends. It's it's like coming home. It's not very common that there is an institution whose invitation I will immediately accept. So any chance to come here, I take without any doubt. There's a small problem with it, coming home. See, when one is at home, one relaxes all the guards and says what one wants. So that's one thing that I have to be careful about. Say things that I should very carefully select words and say. I will try. Thank you especially for thinking of me in the context of INSA-IISER TVM lecture. It is indeed a real privilege. It's I took this topic thinking that I will only be addressing or largely be addressing students, but I see lots of faculty members. So, I may look kind of trivial to the faculty, but I would still not change much. The plan is like this. I will talk maybe for a minute as an introduction of, about INSA, about INSA TVM, but for only a minute, because if I start talking about INSA TVM, I could talk endlessly. So I would be very careful not to spend much time. And then I talk about this idea of questions, how to ask questions and how to ask questions in different areas and different times, and get to things that one is very interested about. And at the end, maybe towards the end, I will say I would talk about one question that I had asked when I was a student, and that kept me going for 50 years, trying to answer that question. Obviously, I did other things in addition, so that I had a job. Otherwise, I wouldn't have had a job. This is a long question, and I would talk about that. At that point, it might become something like chemistry. Till then, it won't be chemistry, I hope. All right. So, about this introduction, I thank again, to have a talk in this name and invite me as the first speaker. I was, of course, willing to come at the very first invitation, because it's always, I have come here many times, and Professor Murthy has invited me. Anytime I get one, I rush. I don't know why. There is this, this eagerness to get back. It's as if I spent just one day in INSA TVM, and that one day happened to be 5 years long. That's the way it was, one long day non-stop. That was the way INSA TVM came about. But I wouldn't spend anything more. I might say something about INSA, but I found out that it is not necessary to talk about Indian National Science Academy here, because several of you are associated with it, fellows of it, young scientist awardees of it, associate fellows of it. So it's not very uncommon. Indian National Science Academy is the national academy officially representing Indian science outside the international fora. We have two other academies, Indian Academy of Sciences in Bangalore and National Academy of Sciences in Allahabad. So these three academies are working in different aspects of science and how to improve science, how to recognize people who are doing science, how to talk about it, how to develop a scientific temper in the country. All of these are, the jobs of these academies. There is also an attempt to, of course, reduce the numbers and merge it into one. Eventually, it might happen, but that's the, one word that I would like to talk about as far as INSA is concerned. ISER TVM, each time I come here, I am really amazed. Essentially, each visit, I find that it has gone from better and better, keep going. The standards of ISER TVM is going up in the numbers and quality. The faculty, the students, the buildings, the environment, the beauty. So I thank the director, the faculty, students who are all working hard to make it happen. So nothing more can make me happy. Somebody who has started this in a simple way in a far off place and thinking that I do not know, will it make it? And I'm so glad to see Professor Murthy, you have made it. The faculty and the students together have made it. So this is really great. I spent a couple of minutes about the first two batches, first batch, not more. I came with this batch of the BSMS students. There is only one student extra here. This is a PhD student from IISc. Rest of them are the 14 students of the first batch. Now, we came to this campus and we couldn't see the campus. We were not allowed by, this Jersey farm. We came up to maybe the initial part, and they said, that's the place, but you can't go through our place, making a mess of it. So then we said, okay, we will go to Ponmudi Hills, so that they were not very upset about the whole thing. This is sometime in September 2008. Ponmudi Hills haven't changed, so they are still there. And where are they now? I have a very partial list. People are moving around. There is Prashant Pathak in IIT Kanpur in a department which is rather new. Pawan Sharma is in the MP Higher Education Department. He's a associate professor now, stationed in Gwalior city, but he actually takes care of educational part. Gopi Krishna is at Macquarie in Australia. Tejasvi in Max Planck Institute. I mean, people are going around from the first batch. There are many others. I have just got 4 or 5. And there were the 3 girls, rest were boys. And where are these girls? They are not there in the country, but Sharanya had started an assistant professorship at Texas A&M this August. And Tanvi is working for IBM, is one of the senior scientists at quantum computing of IBM. And Manojna majored in mathematics and decided that data scientist at a far more profitable business, right? So I then say about the first photo that we had for the PhD students, 2011. Where are they? I have only put 2 or 3 people here. Manil is in IIT Roorkee Maths, Kalaivan in TIFR, Anup Thomas in IISc Bangalore, Priya Kumari in ISER Mohali, and I could go on and on, but I thought this is all I would say about the first batch of BSMS and first group of PhD students. My interest in bringing this is that the current students should make sure that you will surpass all of them. You have to tell them that we can go far beyond. That should be the idea, right? The first batch had its limitations. There was no classrooms and no hostels, and they were running from here to there. Every year or even every semester the hostels changed. Sometimes ISRO says you can use our hostel for 6 months, and then they say we have some other. You don't have any such problems. You have such a beautiful campus. Nothing can be better. So I think you should beat your past, your alumni fully. You should go far, far beyond, right? That's my interest in showing this. You should be able to do that. Now, questions. Questions is what leads to anything, right? We have to learn to question. People say that yes, the more original the questions ask, greater the chance that that nation controls the world. So we have to learn to ask questions. And to ask questions, one doesn't have to be a genius. Of course, genius, they will all ask questions. They will rule the world even otherwise. But one doesn't have to be a genius to ask questions. That habit has to be trained from the beginning. Now, I say early questions. Early questions tend to be very general. What I mean by that is, let us take students who are graduating, with a PhD now, and ask them to write a project on something that they are interested in. Right? Let us ask this, a trial, whatever be the subject. In 99% of the cases, their project will be in the field in which they have done the PhD. Very unlikely that they branch out. There are exceptions, the 1%, but normally that is the case. If you are in, if you are in particle physics, you will not write a project on genomics, very unlikely, and vice versa, right? So there is the guarantee that specialization has kind of trapped them there, right? If you go a little further and asking somebody who just joined for MSc, say physics, think about what would you like to do? It could be solid state, it could be high energy, it could be anything else. But it will be in physics, but it won't be in string theory specifically only, right? Or it won't be in just one area. It can't be in nanophysics. It could be anything, right? There is that flexibility. Now, if you go and ask this to somebody who is just beginning the UG, let us say first year of the BSMS program here, what will you suggest as a project, right? You can expect anything, maths, physics, chemistry, biology, whatever else, right? That is possible here. This is really amazing because it is. We are going to younger and younger generations, right? In age. Let us go to the high school, right? 9th, 10th, 11th, 12th, and ask. Think of some questions that you would like to ask. And it could be anything under the sun or above the sun. I mean, it's just incredible. People will say why the sky is blue. Sometimes in the 8th class they don't know. The answer is known. But they will ask, right? And then find out, right? So there is this general nature of the questioning that comes in. But for this, one has to be encouraged to ask questions. Often what happens in a school, especially in many schools that I have seen, there are some students who will ask questions, whether it is 2nd class or 4th class and so on. They start asking questions one after another. And the teacher gets so annoyed and they'll say, sit down, I don't have the time for this. And when that happens a few times, one doesn't ask questions anymore. The whole habit goes away. And it is very difficult to generate it again. And often the first semester teachers have the unenviable task of regenerating that enthusiasm. So it is tough in the first semester, but that has to be done, right? It is not easy. It is absolutely essential. Perhaps 10 years from now, when the planned new education policy really comes into effect and people start learning, I don't see the right teachers still. There is a possibility, but we can't wait that long. We have our BSMS students here, and we have to learn. So it is also the responsibility of the students to think about questioning anything. I mean, it's not so difficult, but one has to do this. There is no other way. See, it's like it's like the human civilization in its beginning. Everybody did everything, right? If you think of Plato or Varahamihira, they were not just in one or two areas. They were in everything, right? In fact, even before these divisions came up, they were doing this, and that was very interesting. But one has to remember, those who really go beyond the ordinary and see the larger picture are the ones who go above these divisions. There are chemists. There are physical chemists and organic chemists and inorganic chemists. Then there were bioinorganic chemists and physical organic chemists, and all in their valleys. they don't even go above their little hill and see all organic chemists, or go beyond and see all of chemistry. Even that is uncommon. But if you can raise above and see physics and chemistry and biology together, then the problems that you ask are far more important, general, consequential. So this has to be kept in mind. I do not know how to put it across in more words, because that's my request to the students. The faculty are already in their mold. Very difficult to change after a PhD. Difficult, but the students have an option to keep thinking about this. Though I am doing my PhD in an area, I would really see what is happening in the neighboring lab, in the neighboring department, even if it is a person doing PhD in history or social sciences, to look up what happens in mathematics and physics and chemistry and biology, or somebody in biology looking at. I must say, in the first year or second year, we had no space. In 2008 and 9, there was only one tea room. All the faculty, physics, mathematics, biology, chemistry, everybody has to come there. And it started research between physicists and biologists, mathematicians and biologists, mathematicians and chemists. Then we got more space and separated. I hope the interaction exists still. You have enough common tea places so that you can get together. If it is lost, maybe bring it back. Bring it back. Because I do remember in the first few years there were common papers even published. Mathematics and physics and biology, definitely I remember, but there are others together. Now, I talked about birth of knowledge. We gather information from wherever we are. See, ISER students, ISER TVM students will keep talking about ISER TVM wherever they go. Because, when I was in ISER TVM is the way they will begin. I meet them and they say, oh, in ISER TVM, this has happened, that has happened. It is true of everybody. It is the experiences of different places and individuals that make us. So make the best use of such interactions. And I will talk about from my experience in different institutions. Experience that tells me, okay, this is one thing that I didn't realize it when I was in the spot. When I look back, I see this, right? So I'm just going to give a few specific examples of individuals who have gone through this idea of or advantage of breadth of knowledge from asking questions of different kinds, innovation at different range. So I talk about a mathematician who became a biologist. When I was a graduate student, there was a mathematics undergraduate student. He was sure that he's interested in mathematics, but everything else is okay, but mathematics is good. So he essentially did major in mathematics. And after mathematics major, he continued. He was a smart guy, got a Rhodes Scholarship, went down to Oxford, did a PhD in mathematics, and continued in mathematics as a professor of mathematics for next 10 years. But he was always wondering, is that all that I can do? And wondered. So that was the time when the genomics revolution was about to happen. And he felt, I have tried in mathematics, maybe I will shift. And to learn biology, he decided to take a less demanding job. He became a mathematics tutor almost, in Harvard University, and learned biology in MIT after having done as a mathematics professor for 10 years. And he spent a few years learning this, so much so that Harvard and MIT together decided to start an institute called Broad Institute of Genomics. They wanted a director, and they found Eric Lander. The mathematician is the best person. And Eric Lander became the first director of the Broad Institute of Genomics, a mathematics undergraduate, PhD, and even 10 years of working. I'm saying all this to students because you don't really have to say that, oh, I got into this, now can I get out? Don't hurry. There is time. It's possible. You look around and see what is the best possible one. if genomics revolution had happened maybe 20 years earlier, he might not have done a major in mathematics. And if he hadn't done a major in mathematics, he wouldn't have been a good genomics specialist either. Right? So there is a time and place for everything. One has to kind of see. So this is Eric Lander. I mean, something, something really remarkable. I jump again. Let us see our education situation in the country. Now, I'm talking about this with the hope that many of you students who will graduate and do other degrees and PhDs and so on, and get to positions of power, as a group, positions of power in educational institutions and in other areas. It would be nice to see that we change this. Even now, despite the national education policy, most of the time you have to get into a box, right? BSc physics with mathematics and statistics is, BA economics. Well, then maybe there is a possibility of statistics and history. You are essentially put into boxes. And INSA-IISER, I put it, we are a little better, right? We have at least maths, physics, chemistry, biology, and a few other, sciences, data sciences, and earth and so on. But we don't have humanities and social sciences and performing arts and fine arts and communication and so on. They are yet to come, right? It will come, maybe with more time. See, this is not the way the UG program in other parts of the world works. Now, I had to think about this because, after leaving INSA-IISER in 2013, I went back to IISc, and from that time, August 2013 till 2022 August, I taught a course 10 years in a row for undergraduates. And those undergraduates occasionally used to come to my office, one or two of them, and say, am I missing by not going abroad for undergraduate education? And to save my face, immediately I will say, oh no, you are not missing anything, you are in IISc. But after having answered the question and after they have gone, I have my doubts. Why? I have my doubts because if they go to a good undergraduate institution and join and take a few courses, let's say mathematics or physics, history, economics, music, they can experiment in the first 2 semesters, even the next 2 semesters, and then slowly narrow down in the 3rd year to a major, still a possibility to shift, 4th year only really a major. We don't have that opportunity. Why don't we have that opportunity? Not because we don't have those subjects in the same college. I mean, I'm not talking about now the IITs and IISERs, but let's say a college that has everything. But we don't have that opportunity still. Why is it? We have the departments and we still don't have the opportunity because of many factors. One, the parents think that they have to study something like this. The society as a whole thinks that they have to do this, either become an engineer or a doctor, or if, let us say, University College, Thiruvananthapuram, by some magic, let us say, they decided that they will admit 1,000 or say 500 students for undergraduate studies with no restriction as to what they will select. Of course, the next day there will be a big strike of teachers first, forget about students, because everybody will go to mathematics, or I don't know if they have computer science or something. Everybody will go there. There won't be anybody in my subject. I will lose my job. So there are concerns of, real concerns, but all kinds of factors. Even IITs, we say, oh no, if you get admission in IIT, that's the best of it. Not really. You go to IIT Bombay, you are put into a box. Day 1, you are in computer science. you know, 200 or 20th rank in IIT entrance and you will be in. But that is because my father told me to take it. After one semester I decided I actually like English literature. No room. There is no English literature in as a person with, you know, as a major in IIT Bombay still. They have some or something else, music, right? So why are we not changing? The society is not allowing, the teachers are not allowing, the students do not know any better, and there is the worry, will my son or daughter get a job? Will my son or daughter get a job is a major concern. You know, in a developing country that is a normal question to ask. But what is amazing is that those individuals who live in this country as though they are in a developed country with enough money for the next 3 generations, even they don't let their children go and study what they want. It's not just money then. It is not just the concern. It is the very thought that has come through the system. The new education policy is trying a little bit, but no institution is embracing it in the way one would like to take it. Because I talked to colleges in Kerala, you know, oh, we will not have anywhere to, you know, my own college, St. Thomas College, I said, no, we can't do that because we have X number of teachers in each department. And if suddenly only 3 students are there coming to this, you know, mathematics course, well, actually they have dropped mathematics, it's not there. You know, we have to send away teachers, it's not possible. There are many other. IITs do not have that pressure, but even then, unless a decree comes from the government saying this is it, nothing is going to happen. So somehow the new generation of students becoming faculty and coming out and becoming parents, and maybe there is a chance for change. I don't see any other way. What happens is otherwise the rich people who can afford studies abroad will send their kids there. The private universities is finding out that there is an issue there, and slowly private universities are trying to emulate advanced countries. It has not been very successful, but it will be soon. And then instead of $100,000 a year, they will only charge maybe 20 lakh, you know, 1/4 a year and start this. What happens? The government institutions where everybody can go will not have that opportunity, and you know, something dangerous will happen there for the government institutions. I hope it will not come to that. Now coming back to another example, I now will talk about a historian. You know, instead of a mathematician going to a biologist, I will talk about a historian who became a physicist and a mathematician, right? This happened again where I studied. In my year, in 1973, there was a boy who joined in physics. He said, well, I had a history major, but I'm interested in studying physics really. So we asked him why suddenly a shift from history to physics. He said he was interested in history, learned history very deeply, found that he can go backwards in time and, you know, 100 years, 200 years, 1,000 years, 2,000, 3,000, maybe a few thousands more, but cannot go further back. Then he felt he can go further back if he went to physics, even up to the origin of the universe. And it was a big gem. And imagine a department is willing to give admission to a student who had a BA in history for a PhD in mathematics, PhD in physics. He was a genius. He did well. What is interesting is that for developing the physics that he wanted to do, he had to develop mathematics of its own. And for that mathematics that he developed, he got a Fields Medal, though he is a physicist, right? So it's a different level. Now, everybody knows this person, Edward Witten, who started string theory, right? So the reason I am saying all this is you can shift, but one can ask also the question, who takes history in India as a major? Think about it. I don't think that the top 20,000 or 10,000 or let's say 5,000, top 5,000 rank holders of IIT JEE, right? It is impossible to imagine statistically that all of them would like to do computer science. It doesn't stand to reason that all of them will be interested in computer science, and yet all of them go for it. You look at the other end, who will go for history? If you ask outside to the common public, oh, my daughter or son didn't make it to anything else, and there was this college which had an opening in history, and that's what she's doing. Very unfortunate, because there are people and institutions where that's not the case. Now, again, just as you would go and talk about INSA TVM, I come back to Princeton, and they have kept statistics of the top SAT ranks and who all went to history. Usually about 2-3% of the top opt for history, not mathematics or physics or computers or anything else. History. And top SAT scores are about 5%, 2% depending on the year. And they have checked to see what happens to them. They kept statistics for the next 50 years and 80 years. Where do they end up? And they find that systematically a large percentage, of course, goes on to do a PhD in either economics or history itself, or go to management. Ultimately, several of them become CEOs of multinational organizations. Several. History majors. Only in IBM the mathematics PhDs go in. Now, why are they there? They have analyzed it. It appears as though those who are very, very seriously interested in history analyzes it, and they look at last 50 years, 100 years, 200 years, and can see the evolution of time and institutions. And a multinational organization would like to know what happens to that organization in next 10 years, 40 years, 100 years. In other words, they want visionaries as CEOs. And those visionaries are usually historians. I don't want to say the contrast. We have also historians, and they are our visionaries. But we knew who went to history in the beginning itself. You see the problem. So we have to expand institutions to include this, and also see where one can get to the full creative power of an individual. It could be anywhere, history or music or anything else. Now, this is a very specific example that I would like to tell you. Just an event that touched me so much. I joined Princeton, and after a few courses, one can get a master's. And a commencement is the equivalent of a convocation. The term commencement is used in many Western countries. So at the commencement, that is equivalent of convocation, the number one student, overall caliber, number one student of the graduating class of the undergraduates, will be given an option to speak for 3 minutes in the convocation. There is, of course, convocation speakers, commencement speakers. You would have heard Steve Jobs' commencement speech in Stanford, and Salman Khan's in MIT, and so on. But those are regular lectures of the invited person. But 3 minutes commencement occasion is given, chance is given. And in 1974, the valedictorian, that is the term given, the valedictory address, the final address of the top one student in the undergraduates. In my year, this student came up, he has only 3 minutes, and it has to be finished. In fact, it is talked about last year, during this Gaza Strip violence. Many valedictorians were prevented from speaking because the university was afraid that they will say some things that they cannot afford to hear. In fact, I think it was University of Southern California cancelled the convocation of that year, afraid that they have to listen. right? Those 3 minutes. Now, this valedictorian was said, he came to Princeton as an undergraduate, first semester, and he looked around the campus, and there were a lot of squirrels in the campus, and they were all black squirrels. And he felt all squirrels in Princeton are black. And the second year he felt, yes, most of them are black still. And third year he was saying that, yeah, they are black. But he said, right now, I am at this podium as a valedictorian. And he says, look there. He pointed, I see one squirrel there. And the only thing I am certain about is that that squirrel on this side at this moment is black. Nothing else is certain. He said, my undergraduate studies have told me to be asking questions and don't rush to generalizations. All I know right now is that that side of that squirrel is black. In other words, every observation is taken with the idea to question. Right? This is something I felt, yes, that's the role of education. So we have to learn to question everything. If we start early specializations, there is no room to think. You get into physics with maths and statistics or whatever as subsidiaries, and that's it. You don't get out of it, right? These are the general observations I have to make. We started late, right? So there is still, when I was a BSc first year student in University College, and in 1968, University College was the very best college in Kerala, number one, by any standards. Teachers, students, the intellectual freedom, everything. Now I understand that it is very first only in one thing, freedom. But that's okay. But in 1968, there was an excellent teacher. I still remember one Professor Shankarayyar. He was talking about inorganic chemistry, and he taught the beautiful relationship between compounds of carbon like methane and allotropes of carbon like diamond. Methane, ethane, cyclohexane, and you generate diamond. Or take the sp2 hybridized benzene, naphthalene, anthracene, and you get graphite. Graphene didn't exist those days. It was still graphite. And I thought it was beautiful, and he had this, we have this gallery like this, but very small one for the class. Like this only, yeah. So he finishes the class and he's going out, and I kind of asked him, look, is there something like this for boron? Without thinking much, he was talking about carbon. Why not ask a mischievous question? That's the way I put it. Is there anything like this for boron? And he said, okay, let us see. And when he said, come with me, I went with him. He had a copy of Cotton and Wilkinson, Advanced in Organic Chemistry. It was a big deal then because the book came out in 1963. There was an Indian edition in 66 or 67, and in 68 he had a copy. So we looked through and it was not there. So he was not sure what to do, but he said, let us think about it. There was nothing of this kind we can get. Nobody talked about even allotropes of boron in the whole book. So one was worried. I thought, okay, I will keep this in mind. I say I keep this in mind. I tell this to my undergraduate students in IISc. Ask questions and make a list of questions as you go on in the first, second, third years. And some of them do. By the time they finish, there will be a notebook full of questions. If any of you would like to go early, there is no harm in going away. Because I don't mind it at all, because there are other pressing needs as well, right? Now, I tell them to make questions, and I keep those questions in mind. So I tell them that this question, what he said, was just this, and it kept appearing again and again. I went to IIT Kanpur, and I had excellent inorganic chemistry teachers there, Manoharan and Chakravarti. They were on the top of the world. I mean, I felt that way when they were teaching. I asked the same question, and Manoharan said, look, we have an essay to be written. I will give you 20 topics. One of them is about icosahedral boranes. I don't know about boron, elemental boron, but this. But again, there was nothing about allotropes of boron. So I kept this question, and I thought, okay, I will carry it on, and I go to graduate school. And there I thought I will talk to my supervisor. Look, I have been worrying about this. Can we do this? Yeah, but that's a little more difficult than I think I have too many other interesting problems. This is what happens. See, you go there, right? And then, your professor says something, okay, this is what he wants, and this is what happens. But I tell you, it is still important to ask questions. Very important, and keep those questions with you. The reason I say that I had this question, I didn't leave it. I kept it with me. At the public exam, we don't have to defend the thesis in Princeton, strangely. In chemistry department, we don't have to defend the thesis. But we have to give, along with the thesis, 3 research proposals which are not connected with the thesis, which are not connected with one's own supervisor's area even. And then we have to defend those 3 proposals. It's a very good idea, because when you leave, you have 3 research proposals with you. And one of my proposals was on essentially something connected with boron. That's all I can say. I was beating around the bush, so to speak. But I kept those 3 proposals with me. In fact, this proposal of that was my first paper, independent paper, single author paper, only paper from University of Hyderabad from me, but that went to JACS with one author. I have only one author paper in JACS, and that's this. That was published in 82. Proposal was in 77, and so it's worthwhile to keep them. I had one more which I published, but the third one was an experimental proposal which appeared very attractive, still attractive, but I didn't want to do any experiments. Anyway, coming back to this, the question that I asked in 1968, I didn't get an answer till next 30 years. I started getting the answer roughly about 2000, partial answer about 2000. So part of that answer was published in 2001. Rest of it is, is being done, coming in now. So, when you don't do anything else, you don't have a job. So you keep doing other things, and all kinds of other things. I will skip all these. And the latest in that other things is this, essentially pushing the second part of it. First part was done in 2001, sorry. Second part in 24. It's not as though carbon chemistry didn't progress. Carbon chemistry progressed, and all of this came out. Graphene didn't exist in 68, nanotubes didn't exist, fullerenes didn't exist, and all of these people got Nobel Prizes. I mean, even the more recent ones. So chemistry of carbon developed. Chemistry of boron kind of stuck, because it is a little too tough. And when things are too tough, there is one good thing. You can be assured that not too many people will be working, because it is not it's not easy to solve the problem and publish. You can't wait for 30 years and another 20 years for something else. So I try to continue with this, and now I give a preview to the rest of the talk. It's a preview only. The inorganic chemist would recognize this as a Rudolph diagram. Inorganic chemists will see, Clouseau, Nido, Arachno, Wade's rule, and so on. I had expanded this onto this side 20 years ago, and these are all in textbooks. Really, there is nothing, all these are there. Then we have graphene, and there is an equivalent of borafene now made about 8 years ago, and a bilayer borofin made 2 years ago. Now this particular paper essentially gives a way to put most of boron chemistry the way the carbon chemistry is put. So that's the rest of the talk. Now I don't know how many minutes I can go. Maybe I should stop, or I should say something more. We started at so this is the preview of the talk. The talk is only coming in. Let me try going. Okay. So there is a structural chemistry of boron, which of course there is analogous to carbon, hydroboration and body P, blah blah blah, many other where carbon chemistry is followed. Then there is the 2D borofins and borophytes, the 2D boron, polyhedral boranes I have talked about earlier, and an extended Rudolph diagram that fits in all together. So I will only flash something that could be understood by physics and chemistry students of 11th and 12th. So I will put just that part. What 11th and 12th chemistry or physics students can understand. That's all what I would talk about, and then I will stop. Rest of it is not there. So we have this. There is nothing complex. But if you remove B12, H12, 2 minus, and all the hydrogens, this is what we have. It's almost like that, except instead of hexagons, it is triangles. And if you just expand it and say, okay, how about this as a possibility for a borofin? Many people have looked at this. And we were working on this in 2006 and 7. Somebody published just ahead of us, and I thought we have some idea to explain this. Because if you don't have all the, it's like a graphene, except every hexagon has another atom added. But if you remove one atom, then it becomes more stable. This is just binding energy per atom. And at this stage, I made a mistake from a scientific research point of view. The mistake was that I stopped doing this. I had no choice but to stop doing this because I came to ISER Trivandrum. So next 5 years, I didn't do anything in this area. So I thought, okay, it's gone. I did other things, but then I, this is Prasad who did this, and he left, and then I wasn't sure what to do. And fortunately, IIT Kanpur gave me a student ready when I joined back in 2013. I said, look, we were doing this, and then we stopped it. Can you start it again? He said, no, nobody is doing it, and I don't want to now start something. But I convinced him. He looked at the literature, and interesting. He calculated all of the structures that are known in literature, computational work, no experiments at that time, and said, let us look at this trianguline structure where graphene with one boron added, and see how if we increase the number of holes, so to speak, we have the binding energy. He finds that if every 9th atom is removed in this trianguline structure, that's the most stable one. If there are no holes, that's not, and if you more holes, it is less stable, and so on. And well, I will skip these. These are interesting things, but I will not worry about this. When we were thinking about this, suddenly experiments started coming out, 2015, 16, 18, and we found that we have an explanation. This explanation I have taught in 11th and 12th class, and they understood. So what is this explanation? Let us go back to graphene. Graphene everybody understands, and many people work on it. Biologists, physicists, chemists, everybody is working on graphene these days. If you also consider MgB2, where every carbon is replaced by a B minus, a B minus graphene, of course it has to be neutral, so for every two B minus we have an Mg plus 2, so it is neutral. A layer of B minus graphene, another layer of Mg plus 2, and alternating layers. It was a sensation in 2000 when Akimitsu showed that this is superconducting at 39 degree Kelvin, because for a binary system to be superconducting was a big revelation at that time. Many people tried to change it and make it better, but it didn't succeed. Now, if you replace the Mg by a boron, let us assume now, we have Bb2 instead of Mgb2. What it means is that we only have boron, and if we only have boron, the Mg layers, right, the Mg layers which were separate, this will not be separate, all of them are boron. So, the Mg falls into the middle of the hexagon. So, we have a structure like this, right. The only problem in this process is that, well, I have taken stoichiometry 3 times. The only problem is that when we replace an Mg by a boron, we are adding an extra electron, right. Now, if you want to have the same electron count as earlier, then we need to remove 1 electron for each boron that is, each Mg that is replaced. Now, if you have 3 borons replaced, we have B3, B6, like B3, B6. It has 3 extra electrons, 3 Mg are replaced. Now, one way of removing that extra electron will be to remove 1 boron atom, which removes 3 extra electrons. So, instead of 9 borons, if you remove 1 boron, then we have 8 boron, 1 hole, and that takes care of the electron count. And that is why when we remove an electron, sorry, we'll remove a boron, the binding energy becomes best. Maybe I would stop at this stage, because there are far more interesting things about the bilayer and so on, but I think it's okay, we'll worry about it later. Another occasion when I will talk only about chemistry. Let me go all the way back if I can. It will take a while, but well, my summary was this, the preview that you saw, and I have to thank many people. INSA TVM and Professor Murthy for giving this opportunity, Dr. Swati, who was instrumental in planning it all, IPC department, who allows me even now, and I say even now emphatically, I retired 8 or 9 years ago, right? I am still there. This is not common. I still have my office. I don't have a position, but that doesn't prevent them. I could just work still. And I had lots of students across the years. Well, this was a photo in the temporary building. And I do not know whether he's still around. Yes. Okay. I had, until last year, well, earlier this year, I had two postdocs. They are gone. Now I have an army of students who come for projects and MSc thesis and so on. The 2 PhD students have completed, submitted the thesis. And I stop by thanking all of you for such patient listening. Normally it doesn't happen. Thank you very much.
Thank you, Professor Jemmis, for the very insightful lecture. The lecture has indeed left us with many questions to ponder over. Professor Jemmis will be happy to take a few questions from the audience.
Thank you, sir, for the wonderful talk. I was just wondering that when you were saying that we are just sort of forgetting how to understand, like how to ask questions, and as we go younger, the questions become much more vibrant in nature. How much blame would you actually place in the method we generally teach, because it's mostly through trauma? I mean, I do not use that word lightly. It's is the shame, fear of shame of failure, right? That is generally the driving force in our studies, and it is deplorable. Personally, that's what I feel. And and even though that isn't quite what it is, as when you are, say, a 13-year-old kid, that never changes, because that slowly percolates through several classes and then it takes a shape on its own, and that doesn't go away. And when an entire generation of students are going through the same thing, like, do you think that this is exactly why we are where we are right now?
Yeah, I can't agree more. I am not unfamiliar to teaching, right? I didn't teach a full course except for the first semester in INSA TVM. But 10 years I have been teaching in the 4-year BS program of IISc. And the biggest problem that I have in the first maybe 3-4 lectures, 5 lectures or more, is to get people to ask questions. So I don't have the regular lecture. I have, in some ways, which can be roughly described as an inverted class. So we select, I teach inorganic chemistry, not quantum chemistry or, more exciting things. And I took inorganic main group chemistry because everybody said that's the most dull subject. And so I started teaching inorganic main group chemistry, and I say that we will have maybe, 10 chapters roughly, and we will discuss chapter wise. So I assigned for 3 days or 2 lectures, we will have the first group, and the idea is to ask them that you find out many things are outdated in this book. We are talking about come back to me, the inorganic chemistry textbook that we follow, and let us look at this chapter and see what are the factors that are not right in this chapter. Right? Let us analyze in great detail. And they felt it is not going to be easy, but then in 2-3 weeks time they get used to it. So we analyze each chapter and see where there are errors, and where there are examples we take examples from the recent literature that I spend time. And so initially they have a problem, how do we learn anything? So I tell them that don't worry, if after the exams and the semester is over and one more semester is over, after that what is there with you is what you have learned. So you don't have to memorize anything. Then they were not convinced. I said, look, don't worry about the exams. For the exam you can bring all your class notes and assignments, not textbooks, assignments. And so the exams were of that kind. It starts at 6 in the evening and it can go as long as they want. So the question, they cannot complain that I didn't have the time. I did this is not hypothetical. I did this 10 years in a row in the same course. But it took a while to convince, first 3-4 weeks are very difficult in this course, to convince them. And then I found that if I am not careful, they will catch me. It came to that stage. I had to be careful. So by the 3rd month, I really got them to ask questions all the time. So it is possible to unlearn this, but that's an effort. If we can do that right at the beginning of this education, it's much better. It is possible only if the worry about possibility of a job at the end of the studies goes away in the minds of the parents and society at large. Then students in the school and teachers in the school feel more comfortable to sit back and do a little bit more of subject understanding kind of teaching. Right now, have you covered the syllabus? The exam is coming. There was a professor who told me, don't ask even that question. What you are doing is really covering the syllabus. You have to uncover the syllabus, right? It should be known. So what you say is fully right. We have to change. We are beginning. The new education policy is trying in ways, but there is no force to say this has to be the way yet. There's too much of freedom given at that stage that we can find ways to get around it. Or there aren't enough training given to think that way. I don't know if I answered even in a mind way.
Sir, yeah. So thank you, sir, for the wonderful talk. And reminding us to keep up the dreams or the questions which we get in the early stages of the science or research. Sir, I have a small doubt. Have you ever tried to do any experiments to see your the theoretical calculations or your results?
I'll put it this way. In 2001, part of the problem that I meant, I said the connection of polyhedral boranes to beta rhombohedral boron was solved. In that solution process, icosahedral boranes can be condensed with another icosahedral borane, so you get a condensed polyhedral borane, and you can do it in many different ways. Benzene to naphthalene, there is just one way. You don't see many other ways of doing it. 6 years later, 2 groups in Germany actually made those compounds with the right anions, right charge, and so on. So I haven't myself done, but many others have used these things and done many chemistry.
Thank you, sir.
Yeah, I am a poor experimentalist.
No, sir, I'm just curious about it. Thank you.
There is one question there.
It's a pleasure listening to you, sir. So my question is this. From the schoolings to the PhD journey, we are going through a narrower path for the sake of specialization. Do you think this specialization is the cause for us to look into the bigger picture of the world and science world? And what would be the countermeasure for this?
Yeah, I wouldn't say the specialization per se is the reason. I would say as we go along, look around and see who is your neighboring lab's PhD student in your area. What is he or she doing? In the neighboring department, if you have that open interaction, already you are not really restricted to your own field. This is true of everybody, faculty and students. It is not necessary to stop PhD work in the middle and go and see another field. But you have to do this in a way that, I don't see the option. See, there is no pressure in doing it. In Princeton, there is one pressure at least one time, and that is while submitting the PhD thesis. Along with the thesis, one has to give 3 research proposals which are not connected with the area of your own supervisor. And those 3 research proposals have to be presented and defended to get your degree. Your thesis is not to be defended because it is assumed that there is a doctoral committee and most of these results are published, and the doctoral committee meets every semester and looks at what you are doing. There is no question that you have reached that far. So that is one way of pushing a little. There should be other ways of expanding. So the answer is that it is not the solution is not in stopping the specialization. If you do not go deep into an area, you are not pushing the frontiers. But along with it, you should look at the frontiers on other areas. I will suggest one way. Subscribe to the weekly news that Nature magazine sends you. It is free in all areas. Read at least that much. Just that.
So we can get wide aspects of other
That is
fields.
right. In fact, I remember, the ride from where I used to stay in Trivandrum to CET, INSA-IISER at that time, takes 20 minutes at 7:30 in the morning. In that 20 minutes, I read through the Nature magazine, and I go to the first year class at 8 o'clock. I will be there 5 minutes before, and often the teachers come maybe 5 minutes late, and I have this 5 minutes to talk to the first year BSMS students, and I talk about just that little introduction of a topic that has come out the previous week in Nature, and each week something else, right? And the students think that there is something unusual coming in, but I see them 5 and 10 years later when they are on their own looking at this, and they felt that's a thrill. So there is no harm in doing that kind of a concerted effort. It takes few minutes. It comes on your phone. You read through. In fact, today in which department it was? Biology department, right? There was a presentation, and sure enough, today morning came a nature briefing, and I had looked at it just after getting up, and the second person who presented this work was in a way connected with this, and I could say, look, this has come out. And the faculty at INSA TVM are much smarter. They had circulated it day before yesterday already among the faculty. So you have to keep looking, and you see the.
So if I may to add on.
Yes.
So how likely or how feasible for a chemist, fully featured chemist, to jump into a field of biology? How it is easy for them to start from the scratch to build it up?
Well, I will go
Thank you.
back to Eric Lander. If he could go from mathematics to genomics, right? Physical chemist it should be a cakewalk. Compared to a mathematician going to genomics, it should be possible. Or a historian coming to theoretical physics, right? There is one thing though, the attraction to a subject should not be the result of a romantic idea about it. This is important. See, there are people in +2 who think that origin of the universe is a great idea. I should work in theoretical physics. But if the person has difficulty passing even regular mathematics classes, there is a danger, right? I have again, I come back to my institution where I spent 5 years at a stretch. The only other institution I have spent 5 years at a stretch is INSA Trivandrum. The other place was Princeton. So when I joined, there was one student who was in the 1 year senior to me in theoretical physics from Delhi University. He was a top ranker in BSc and MSc, and he got admission in physics in Princeton. Should be a smart person, but he wanted to do theoretical physics, high energy physics, and he had difficulty passing the comprehensive exam. He barely passed, and they advised him, look, it's best that you leave. You will not survive here. And he was a very smart person. He decided that he will leave. Where did he leave? He went back to India, did a PhD in JNU in economics, and became a very famous economist. His name is Arun Kumar. Occasionally you see articles by him in Hindu even now, and his articles are taken very seriously by economists across. So one has to find what one can do in the best possible way at the cutting edge. That is very important. So there is the necessity to see where one can do the best. That's also there. Yes, yes.
Hello, sir. So throughout the talk, you have emphasized on the importance of asking question. But unfortunately, in classroom, due to lack of time and schedule to complete the syllabus, it's not possible for teacher to answer all the questions. So what is your opinion on introducing a concept called virtual teacher or something like a chat GPT or Google or something in the national policy so that all questions can be answered?
Yeah, I think different teachers have different ways of handling it. At an individual level, my answer to this was, I go to my office and when I'm giving the course, I have said any student till I leave the office can come and knock at my door. If they don't see me, they should send me an email. And I promise them an answer. If I don't, we sit together and find an answer. It's difficult to practice when there are large number of students. I don't know the situation, but my solution is that I am accessible to the students as long as the course is going on, without any question, at even the risk of keeping many personal things away. This national policy and all, it's easy to make policies very difficult to enforce. So each teacher has to kind of feel this, and each class has to kind of get the teacher to feel that. Right? Both are, it works both ways. If there is an interesting set of questions coming in from the class every day, I'm sure even the teacher who is not so very keen to entertain questions will change. I don't know, that's my feeling.
Hello, sir.
And I finished 12th class. Before I finished, in the 12th class, the debate was whether I can take science or arts or humanities. You know, the decision was this decision was based, or rather the question was asked because the science stream in BSc has laboratory fees, and the question was whether we can afford the laboratory fees. I was about to take BA Malayalam Literature, and I like Malayalam literature, even though I can't even speak nowadays. But then, you know, there is something called NCERT. It conducted a national science talent search examination in my second year of +2. It's called pre-degree at that time. And there was a written test, and there was an interview in a great institution called Indian Institute of Science. So first time I went out of Kerala in 1968, January, to IISc, and there was this interview, and I got this scholarship which paid for undergraduate studies if you take science only. Later on it was expanded to other subjects, and my dilemma was solved. The fees is there. So such luxurious question, I mean, any day if I have a chance to come here, I will ask them, you know, everything under the sun. In the first year I will say, look, you know, why should I study this course? Tell me some good reasons. And I'm sure your teachers would give answers, because, you know, if you want to do anything at all, you have to learn more, right? You cannot say that I will solve Fermat's last theorem. Oh, but I don't want to take any maths courses, right? I mean, it's not possible. So you need to, I mean, but, you know, let me also say this to the first year students. I had a classmate in University College, Trivandrum, first year BSc. Actually, there are sad stories as well. So he was also a national science talent scholar. Maths he took, and he only wanted to go to number theory to solve Fermat's last theorem. He didn't learn other branches of mathematics. and got a third class in BSc and cannot continue the scholarship. In my first year, there was a second year student, one Shankaran Nambudiri, also a National Science Talent Scholar, wanted to do the same thing, solve Fermat's last theorem, and he failed BSc and he couldn't take it. He committed suicide. So you have to be realistic. You have to be realistic. That is, there are limits of what one can do and what one cannot do. So courses, I mean, if there was a tough teacher to tell him, Fermat's last theorem you can solve later, take all the maths courses and maybe give a beating. But University College was a free place. Nobody said anything. You are free. You can come to the class, you don't have to come to the class. But this is what happened. He was very serious, but a genius cut off early.
That was truly an engaging session, but in the interest of time, unfortunately, we have had to cut it down. Thank you very much to Professor Jemmis for spending a nice evening with us amidst all of us today. Please join me in thanking Professor Jemmis again for a very, very insightful lecture. May I now invite Professor J.N. Murthy, our director, to hand over a souvenir to Professor Jemmis on behalf of the institute. Thank you very much. With this, we come to the end of the proceedings. Have a great evening. Thank you all for joining again.